So we can start out by finishing the pieces. Make sure you don't have any rough edges on this part or on this part, because that's going to go here and capture our Scotch yoke lifter. And also light filing on this, keep any rough edges or squished elephant's foot type of print off of it. And I used a little bit of a sanding and scraping here, just lightly, so that it fits nicely into the BadMotivator that we'll mount later. So all these pieces should be nice and smooth so that you have a clean but not too loose of a travel. Okay, so once all the pieces are cleaned up, it's time to mount the air pump housing. It's held together with two more screws. Just drop that little screw into the hole, as so, and then just a little teeny screwdriver. And that should be tight enough. Make sure this is flush, because later on when we mount the pump, it slides over the top of that. All right, next we'll put in the buck converter. This is a 20 amp capable buck converter that I've set to, mine's about 3.7 or 3.8 volts. You want to use a Ohm's law calculator and look at the wattage rating of the vape coil that you're using. So make sure you don't oversaturate that with voltage, because it can cause a fire. How do I know this? You may see some videos with burn marks on my breadboard. So be wary of putting the wrong voltage onto that vape coil, because it'll heat up fast. All right, so that's all the preliminaries. And then we'll mount the relay for the smoke. And these are more number 4 panhead screws. Here's an example of how you don't want to twist the board, because right now that is caught on one of the screw threads and doesn't want to lay flat. There we go. And finally, we have the air pump. And again, mine has been used in the testing. So I've already got my hose attached to it, and I don't feel like pulling it off again. And the wire's already attached. So the way this works is this little notch fits into the pump and captures the whole device like that. And just grab a couple of the 3/8 panhead. And this is also designed so if you have a different pump, you can have a different casing on the pump, and is designed so that you can change the pump pretty easily, because although it's held in with 4 screws, only 2 of them actually hold the pump in its location. And there's not a lot of plastic here, so don't over tighten this. Okay, that pump is in position. Okay, at this point we want to figure out how long to make the wires that go from the buck converter to the pogo pins. And I would say you want to make them just comfortable to reach the pogo pin without having too much excess. And when we're putting it together, we're going to kind of fold it on top of itself like that. So you want to have it long enough to root through the strain relief here. It'll go in front of that. And then over to the output of the buck converter. So this turns out to be 250 millimeters or so. So I'm going to cut those, and this wiring plan, I'm going to put a spade connector like this onto one end of the wires, and the other end is going to get soldered to the pins of the pogo pin adapter. That way these won't have any pins extending out when you are handling it, and then when you put it in, the pins will actually be sticking out of the base. So I'm not really teaching a soldering video, but make sure you tin the wires before you try to attach them to the pins. I tend to let it melt onto the head of the soldering iron, and then apply a little bit of solder, and then it soaks into the wire. I'm going to put the ground in the middle. You want to put solder in here so it sticks, but you really don't want to fill it up with solder. And then when you're done, you want to put some shrink wrap to protect the wires. Make sure you don't drop anything across the terminals and have them short out. Alright, so you got the pogo pin connectors installed. It's time to mount them with some screws. There's two flavors of this. One is the metric and one is the imperial. So the metric is 2.5 millimeter screws, and the imperial is a 440, a number 440 machine screw, both flathead, and it just depends on which one you bought. I happened to buy the imperial ones, not realizing there was a difference until I tried to put an M3 screw in there and found out that it didn't work. I went to the spec sheet and found out that I'd bought the imperial one, which is listed in the bill of materials. I'm going to update that to the metric, or just let you know that there's an option. Okay, now that I've got the heat shrink on, either an M2.5 or number 440 flathead screw, and then I'm just going to do a final measurement now that everything is actually in place. And looks like I've got a little bit extra wire on there that I can take off about that much, and it will work just fine. So for these, I'm going to use they're called Spade Connectors. I just try to make these the same length. That way wires don't have an unnecessary kink or twist in them. And make sure the wire connector you're using meets the wire gauge requirements. In this case, these blue connectors are rated for the 12 gauge wire. Just give it a little twist. And you can crimp them with any old thing, but I ended up getting this nice crimp tool so I get a good consistent crimp. And I'm going to look and see which way I want these laying on the wires so they don't, again, have any extra twist in them. Alright, so they're going to sit like that. So I kind of want them on the inside of this curve facing up. Like so. And I'll just give it a little tug, make sure that it's actually crimped. And I want to mount this one in the same orientation. Again, just to make my life easier. And not ask anything else from the wire. That's not necessary. And again, a little tug. So this part is done. They're going to get connected into there when I do the final assembly, but I'm going to set this part aside for now. At the very top, the 10 amp relay. And then it's going to go the 30 amp relay, Wago connector, and then finally the Arduino. And for the Arduino, you probably want to mount the Arduino so that the USB connector faces forward, so that way you can get in there with a programming cable and program the USB. And it's got little ears that grab the sides of the board and keep it in place. That's how that works. But all of these connectors will mount with number 4 machine screws, which I kind of like. They're a little cheaper, a lot cheaper, and they grab the plastic just fine. But the same hole will also accept an M3 10mm. M310. There's a couple places where I use metric in other screws, so if you want to have all metric or all imperial, it's very possible to do that. It's just a matter of what you have on hand and what you want to buy. Okay, we'll start at the top. Just poke that through, line it up, and just start it. Anytime you're doing screws into plastic, you want to be careful not to over tighten the screws. So step 1 is just to get every screw started so that the you're not inducing a twist or a stress on that plastic. that will cause the other holes maybe to misalign, or you to get the mount kinked at an angle where now it's grabbing the sides of the through screw threads. Have the mount come out of its place, or have the screw holes get stripped out. Alright, so you don't need to watch me tighten these screws down, but I'll do one set just to see, so you can see the technique. So the object is just to get the screw snug so the piece doesn't wiggle, but don't keep tightening it until the piece cracks, because you're perfectly able to do that with this amount of torque and stress on these little plastic pieces. Alright, so it's not wiggling and there's no gap. The screw's entirely flush, if not indented a little bit, and that's what I want. The 10 amp relay is mounted with number 4 panhead screws. You can continue using the flathead screws if you want, but I have them here, so it just seems like it's the right screw to put in there. So this is the output side, this is the input side. I'm having the output side face the back so that it will have less wire kinking. In the original design, the air pump was higher, and I didn't move the relay lower into the build. There's no reason it has to be on the top, but everything just kind of fit in the spots that they gravitated towards, and it's really, that's what led to this format. And you don't necessarily have to put 4 screws in each one, but I like to. It's my little OCD thing. You could put diagonal corners if you wanted. They're not going anywhere. There's not really any stress on them. But here's what I was talking about earlier about these screws. These threads can actually catch on the end of the board and twist it. So you want to make sure the board is parallel in both X and Y, so you're not giving a twist to the board as you tighten it down. And it should be sitting flush on the mount. And again, same standard. No wiggle, and we don't have any stress on the board over the mounting process. There's multiple mounts on the hard drive. Just pick one that fits the hardware. They some of them are labeled by their part number, others just simply by their dimensions because we couldn't find the part number. You should be able to take some calipers out and just measure your device and see what form factor it needs. If you find one that I haven't covered, just let me know the dimensions from here to here and the dimensions from here to here, and I will whip out a custom mount. That's why these don't mount directly to the body, so you can put any hardware that you can find locally onto these spots, and it's just a matter of getting the right mount, which are fairly easy to build. All right, so one question you may have is, why are there 2 relays? Well, the simple answer is this one is going to be running a 12-volt pump, and this one is going to be running the 3.7, 3.8, whatever your vape coil requires. And these are just basically, think of them as light switches, or in this case, pump and vapor coil switches. So that's why you have to have 2. For the Wago connectors, this is a super tight print. It's meant to be friction fit. So what I do is I put it in, go to the wall, and just kind of rotate and push this back corner straight down, and then snap it into position. See if I can show that from a different angle here. So if you get them at an angle, they're not going to go in. You have to get them square. like that. Just kind of push rotating down. And the lip here goes over the casing and holds it in position. Again, mount this. It'll go both ways. The telltale is these rear pegs. There's a little hole right here. Some Arduinos come with the pins soldered down, and that's allowing you to have clearance to mount the Arduino in there. Make sure you get it all the way up under the little ears here that grab the board, and then just this little end cap with an M2 screw should fit nicely over that, and a little jeweler screwdriver will hold that in position. There we go. And it's okay if it has a little wiggle to it. It's not going anywhere. And then finally, I have my DC 5-volt bus. This is just a little breadboard that I got off of Amazon. And what I did is I connected these two jumpers together, here and here. And then there's a jumper between here and here. My soldering is not the greatest. But what that effectively does is it makes all 8 pins north of my fingernails. You can see I labeled it positive, and then going the other way, all those are negative. And you can plug in your power cables. Like for example, I made a little power cable. If I straddle the plus and minus like that, I can then power up. In this case, this is my Arduino power cable. You can see the plus and minus. And you can see I plugged it in backwards. Do not do that. Never, never, never power something up unless you've double, triple, and quadruple checked the polarity of these DC components. Otherwise, you'll induce some blue smoke. But that's just for show. And this gets held into this little adapter here with a single M310, or in this case, a number 4 3/8 wood screw. And I didn't have any of the shorter ones. It should kind of snap into that little channel there. So a single screw just keeps it from popping out, and the rest of the assembly holds it into position. All right. So that's nice and snug. We have all of the components on this side of the main mount in position. And these wires are in here just because I am tearing apart the last version to build this version. And I just didn't take all the wires off. So this is the button holder. You can see what I did was I soldered this 26 gauge wire. And what I found helpful is to take your screwdriver and just stick it between here when you're tightening it. And these are super fragile. This is a 10 millimeter. And just hold that and keep it from spinning. There is a lock washer in there, and it can be kind of tricky. But each wire has a signal and a ground. And the grounds are all going to go to the main DC bus here. And the wires are going to go to the Arduino. And each one is on its own pin. And what I did was I gang loaded all 3 of these together in the same clip or the same casing. That way it's less likely to fall out. And it also gives each pin a little bit more grab. And if you plug it in the right direction, it's easier to take apart, and you can even label it to which side goes where. So the grounds will want to live together, and the signal wires will live together. And if you look, the top one goes to the top when I'm facing these the side where you can see the metal. So that'll be important later when we go to wire it, so we know which button goes where. So these all go into this chamber. And you'll definitely want to solder this before you attempt to install it, because you're not soldering it in position, you just won't be able to get access to it. I find it helpful to have a pair of tweezers handy to wrangle the wires into position. I like tweezers like this. And these are super fragile wires, so just be gentle with them. They don't need a lot of electricity running across them. And this is a number 2 wood screw with a pan head. There's a little notch where my thumbnail is that goes into a little notch in the main mount. So you want to kind of seat that and then rock it backwards so that it's captured in position. And then it's not a lot of room for it to have a bigger notch, and it's not a very big notch. So if you're having trouble lining them up, make sure you've looked at that notch. And then a simple screwdriver. All right. And I'm trying to be careful not to mess up the wires. And then the final switch gets mounted on top. This is the reset switch. And just so you can see the technique, I'll mount it into here. Again, tweezers are your friend. Gravity is sometimes your friend. There we go. So I'm just going to spin this and push up on it so that the pins, I'm trying to put stress on the body, not the pins. If you have problems with this step, lock washer and nut, try reducing the amount of springiness of your lock washer. Sometimes they are stuck out way too wide and you can't get the nut on. It wasn't sticking through all the way. That'll make it easier. Okay, once it's started, 10mm wrench. And again, this is not, you can actually break these. So just get it so it's not loose. It's not going to spin on its own. And that's all you really need to do with it. Just kind of flatten that lock washer. All right, doesn't wiggle. As far as wire routing, these wires go through this little hole here. Right here, that's the channel for those wires. You can see there, that's the hole for the back button wires. And the top ones go through, and this one may not be obvious to you, but you got a swinging pendulum here. And so there's a bar. You can see this bar here. You want the wires to come from here, under the bar, and then out here. So they are not loose and they're somewhat captured in the structure here. So you're not going to end up with wires getting tangled up in your bad motivator. Because why? That would be bad for your motivation to have your wires get tangled. So you can see, just grab that, stick it through there. There we go. And being super gentle with the wires, I don't want to pull or tug them too hard. That little twist I want to kind of untwist so that it lays with no stress on it and is fairly relaxed. And when you're done with these, there we go, see how that kink's coming out. I kind of push them down to the back because we got another set of wires to run through, and that's the LED wires. So that's yellow is digital in, red is 5 volts, and of course black is ground. Number 2 screws, there's little spots here that would line up hopefully with the one you bought. And the one I bought are similar, or at least close enough that these screw holes, preset screw holes, will work. If they don't, you're gonna have a heck of a time trying to get this to line up. So what I would do is line it up to where you want it and just pre-drill these holes if your LED is a different form factor than this one. When you're soldering the other set of pogo pins, what you want to make sure to do is put the heat shrink onto the wires before you actually solder it. Otherwise you won't be able to put it on there. Okay, so when it comes time to put the magnets in, what I do is I mark one side with an X or a plus or whatever, some mark, and I also mark the magnets with that. So that means to me that plus goes to a plus, and it'll be blank on the other side. And that way it helps me not flip magnets around. And I use some Gorilla Glue gel and zip kicker to attach the magnets. You can use 2-part epoxy if you want to, but I found that this is much quicker and easier and less messy, and you can basically put the Gorilla Glue into the hole and then get the magnet perfectly flush and then hit it with zip kicker and it just stays. You don't have to worry about it twisting or mounting or getting pulled by magnets as it cures. So I do one at a time on one side and then be very careful doing the other side. And I'm going to pull this out just so I'm not messing with glue on this when I'm putting the other opposing magnets in. Make sure you give it a good shake. And then I've marked all the tops of all the magnets with one mark, and I put that mark inside here indicating that those two faces go together. And I'll just coat the bottom with a big squirt of glue, because I've got the holes slightly oversized in case your magnets are different than mine. And then drop it in. And then what I want to do is make sure that that is perfectly flush. And right now I push it in to kind of get the glue up around the sides. And then to pull it out again, I'll just take something metal so it'll kind of attract. And now it's flush with the surface, although it's got a little bit of an angle to it, and I don't want that. All right, I decided to put more glue in there. It doesn't have enough to float on the area I want it to float. I use this to kind of make it flat. I'm pretty happy with that. When I am, I just hit with zip kicker. And that looks like a successful magnet. I'll do this 7 more times to mount the other magnets. Before you mount the LED, you want to check that the Scotch yoke lifter moves freely. It shouldn't have too much play or too much wobble in the up and down. And I just temporarily put the base on it. And you may find that your printer has left a bit of goobers on the surface because this is printing without support. So this interior rail right here might need a little filing. And you want to do that before you mount the LED ring. Before soldering the wire onto the bottom of the 510 connector, make sure you put the nut and the ground adapter onto the wire so that they can be attached later on. Alright, so here's the final tank holder. I used a wrench to hold the nut and just kind of tightened it by pushing to the side on that. I got the power on the bottom, the ground in the middle, and these screws here should be flush so they don't prevent contact with the other side. Okay, so I've got everything put together now. I screwed the target or the pogo pins into the base and the targets here. Now I'm going to check to make sure that the pins are mating. So I'm going to go red to red, and I get a nice signal. Then I go black to black, and then red and black aren't touching. And the same thing here. I'm going to go to the center and make sure that is connecting and the outside is not connecting. So this is a valid circuit and it's ready for power. Okay, before I put the two pieces together, I want to wrangle all of these wires through this hole here. I'm trying to get them too tangled up. So I should have 3 black wires and the yellow wires all connected together. You probably won't have them all connected together at this point because you didn't take one apart and start a new one. Or maybe you did. Okay, so all these wires are out and free. You can see they go through that little hole there. I'm just trying to keep them from getting too tangled and kinked and twisted. And you want to make sure I didn't have any super small shrink wrap. I would have liked to, in fact I need to buy some for these terminals. But that's what that looks like. And now it's ready to attach one to the other. This is simply going to take, right here it says out and it's plus. You can see that. So I'll take the plus side. I'll do the minus first since it's got farther to go. And just slide it under these don't know what they're called. Little wire keepers. For some reason it has a wiggle to it. I don't know why, but I was stabilizing it so it wouldn't twist off. And then this part will fold back in on top of the and so I'm just going to attach this with some looks like they're 15mm. Yeah, 15mm M3 screws. Okay, so it's time to mount the servo arm on the servo. You can see the servo is mounted from the behind with the screws that came with the servo. For the servo arm, I just embedded the servo horn into the printed piece using gel, super glue gel, and zip kicker. And then I just need to approximate where the servo is in its rest or closed position. To do that, I've loaded up the sketch and I'm powering the Arduino with USB, and I'm going to power the servo temporarily with ground, skip a pin, 5 volts, and then pin 5 for the servo. And when I connect that up, it will move the servo to its resting position. Okay, so that's where the servo thinks it's closed. So I'm going to pull this arm off, then position it up to where I think it's going to go eventually. And then I'm just going to do a test and see that the servo, if the pin were in it, this would be at its bottom position here. So that looks pretty good. Now you don't have to do this step. You could start with a servo in some random location that's kind of in the middle. You could mount the servo arm using a servo tester to put it at 90 degrees. But then you're going to have to tweak this position in code. And since I've already tweaked it in code, you could start with the code, and that way you're one step ahead with this mounting. So let's pull all of this off and install the servo screw, which can be a little bit of a chore. So that's just so we don't have to work around these wires. We'll pull this off and then drop. There's a whole convenient, whoop, oh, I didn't anticipate that. This can be a little tricky. You want to kind of get all this sorted out ahead of time so you don't have to do this when it's in the dome. Although it's possible to do, it's just more of a pain. And then this part slides in here, and it's attached with 4 3/8 number 4 screws. And finally, this is an M425 that will screw into the servo arm. And what you want to do with this is take out all the play. Don't make it so tight that it doesn't move easily. So put a little M4 washer on there. I want to take all the play out, but make sure it's not binding. So it's going into plastic, so it acts as a lock nut. And then I'll take the servo tester, which doesn't run its full range of motion, but it'll give us an idea if the servo's overloading or it's working too hard, or if there's any binding. Alright, so once I've got it plugged in, I'm going to just test free range of motion. Just put it into the servo and let it oscillate back and forth. So it looks like it's chattering a little bit. So I'm going to check my alignments and make sure that it seems like it's chattering on this part here. Yeah. So I'm going to maybe do a little sanding and fix that. Okay, so the final step is to take the chimney, and it kind of screws in to this spot here. It's not meant to be glued or screwed. It sits in this little groove. That way it can play a little bit as you remove the tank assembly. And then put the yoke up and screw on the BadMotivator. And it should come tight just as it hits the front. Kind of make sure it's parallel. This is the BadMotivator final assembly, just about. I still have to wire it. I've got a wiring diagram posted online, and I'll wire it up and test it, but this is the version 2 of the BadMotivator in its initial assembly. It'll be almost done. It's been a long wait, way longer than I thought it would be, but hopefully this will be worth it. So we'll spend the next video wiring up and testing. Stay tuned.